Labor demand, how much we want to buy. Now the wage is what we're measuring here. So when we say, well, how many people would you like to hire if this was $10 at $12, then it's a change in the quantity of labor demanded. What's a shifter? What would change there is you said price, and so the price, there is a shifter of labor demand for the businesses on how much labor they want to hire related to the price.
Some happen
But what price? A price, I should say. But
some happen to the workforce that would shift it.
Strike.
Like a strike or something.
Okay, yeah. Well, that would be So that might change the supply would shift with maybe a strike or something.
The demand.
How does a business come up with their demand for labor? So the demand for labor. How do I decide whether to hire somebody or not?
Whether it's
What's the most I'd be willing to pay for somebody?
the most it costs for the machine to do the job.
Well, we'd look at alternatives, but what would cause me holding machine productivity constant? How would I determine how much I'm willing to pay somebody? The maximum willingness to pay somebody's pay.
The difference between the selling price and the cost of the product.
You can like the productivity to where they're like last unit of production is equal to the cost to make that unit.
Okay, so it has something to do with their productivity, right? I hire them, they're going to make something for me, right? Or they're at least part of the production process. And so that was the marginal product of labor. This is the change in quantity by adding an extra person or an extra hour or whatever the case is. So that's their productivity. How do I convert their productivity then into the maximum amount I'm willing to pay? What piece of the puzzle's missing now? If I make hamburgers and I hire a Russ and one Russ can make 100 hamburgers,
Price of hamburgers.
the price of the hamburger, right? So that gives me the marginal revenue product from the extra unit of labor. So in a competitive market, the marginal revenue generated by these extra hamburgers, you can think of the change in total revenue from a change in a hamburger. And so what the demand for labor is really based on is how productive are you and what can I sell my product for? So I hire an extra person, how much extra revenue does it bring for me? It channels through them making product and me being able to sell the product, but that's our demand for labor. So that's kind of always hidden behind the scenes here with the profit maximizing company on the labor demand function is the incremental amount of revenue. So in in competition in a competitive market, price equals marginal revenue in competition, which is often what we assume. And so now it's just the price of those hamburgers, right? So that would imply price times marginal product of labor equals my demand or my marginal revenue product. For this class, we're pretty much saying the demand for labor demand. Okay, so there's the price I was looking for, bing, bing, bing. If I can sell my hamburgers, I used to sell my hamburgers for $5, but now I can sell them for $7. If I can sell my product for $7 because it's in demand and it used to be $5, can I hire more people or less people? More. So demand for labor goes up, puts upward pressure on wages, blah, blah, blah. Okay, so this dynamic here, thinking about the businesses and their supply, here we're looking at we've got both in here. The supply of labor comes from the households who need to live somewhere. And so the wage that they earn ends up playing into the amount that they can bid for real estate or land in a particular city. And so the monocentric city says that if there's agglomeration economies and other things of face-to-face business, the business is going to be able to outbid the residents when we're closer to the center. But as we diffuse out, those benefits become less, and so now the residents can outbid the businesses. Okay, questions or comments there? All right, so then this is about where we talked about the streetcar, right? So the streetcar allows residents to bid higher for residential ground because it's cheaper to commute to town. And then it also might increase the distance that the residential area would make up. With the higher or the lower wages because of the change of the streetcar, the businesses now could maybe expand their business area too. All right, so there's kind of that dual effect, which is about where we left off. So here, I don't think you guys saw this one yesterday, right? Okay, all it is kind of a summary of what we showed on the previous two. So the old one is these thinner lines, and so we get this combination of businesses with the streetcar being able to have lower wages, residents being willing to accept lower wages, and so expanding out the area. And then we've got the agriculture in here. Basically, a combination of those two effects makes the business area grow. All right, so it's kind of conceptually just putting together how cities might build out and why we see prices. Remember, we had those cool graphs that were three-dimensional that showed the bid rent curves in different places. So this is just kind of exploring more of those motivations. All right, so what happens when we loosen up some of the assumptions? Why don't you go ahead and give this a read? I can't remember, did we do this one too or not? Well, we'll repeat it here if we did. What's this? Okay, so the words here are saying with the current model, the way we did it, we have these areas. I kind of like this one better. We have these areas growing, and they're kind of chunky because we're not taking into account the ability for substitution to go on. So what is the substitution? What are the implications of having these two types of substitutions? So what would the consumer be substituting in terms of density? What's a substitution that they could make in their living quarters? What do we see in the city in terms of the size of places? You guys know some friends maybe that live in the downtown area.
Small apartments.
Smaller, right? And cheaper? No. So 1,000 square foot in Ottawa versus 1,000 square foot in downtown Kansas City, there's a big difference. And so the first would say, oh, I can't afford that. Well, now a one-bedroom apartment, instead of being 1,000 square foot, you can still pay the Ottawa price, but you only get 600 square feet, right? So per square foot, the pricing changes. So the consumer is substituting the size of the place with the dollars and the other conveniences that the city life brings you. So that's the idea of consumer substitution that we held constant here, which means then what's going to happen to density of residential places if consumers are allowed to take smaller places, even if they pay higher prices? What happens to residential density? It goes up, more people. So now we've got, we have 100,000 square feet. Everybody's willing to take a 600 square foot apartment instead of a 1,000 square foot apartment. Now I can pack more people into that, right? So density is going to go up in those areas, which would offset some of the impact that we saw with the previous model. And then input substitution. So input substitution is the business with labor and machine or land and capital. What are they going to do? What happens as they build taller buildings? Per square foot, what happens?
It's more expensive.
It gets more expensive. So when they're allowed to now substitute for land prices going up, we can build higher and still get the benefits and offset it. Okay, so that's going to cause denser and denser areas. All right, this last thing, we won't spend a lot of time on it, but he brings in sea level rising. So I guess maybe motivated by climate change being a hot button here. So Carlos spent some time in Miami, and there's talks about Miami's going to be under the ocean. You know, just give us another 100 years or so, and rising sea levels are going to make Miami an aquarium, right, or something like that. So I think that's his motivation. This is the last part of the chapter. And so if at the city center there basically is real estate taken off the market because it's flooding, you know, what's going to be the impact overall? And so this gray area is supposed to be, this is where the businesses were and they were willing to pay a whole bunch, but now the center is kind of removed and it's compacted, and so what's going to happen to prices? And so he kind of goes on to say there'll be a redistribution of money, people leaving the area, and adjustments to wages going down now that they're in the rising sea level area. All right, let's do a problem. You're gonna have to get your calculator out for this one. Number 2. So centralized versus dispersed offices. Consider an office firm in a monocentric city. The labor cost function is 60 minus 6x, where x is the distance to the city center from 0 to 5 kilometers. The interaction cost for travel between office firms is 12 plus x raised to the beta power, where beta is a parameter, a variable that's beyond the control of the firm. Based on the earlier discussion of the travel cost of firms, a plausible value of beta is half, 1, or 2. So why don't you guys just kind of play around with that, check with your neighbor. Maybe you can kind of exchange trying out some stuff here with the wages, what's happening as we move further from the city, and then what's happening with the interaction cost. And it might be easiest to start off with beta equaling 1, because what's anything raised to the 1 power? It's what? Itself. So that's kind of an easy one to do. Otherwise you get into square roots and squares. So kind of do some calculations, see what that looks like. So, have you experimented with some different betas? This thing says, based on the earlier discussion of travel costs of office firms, what was the idea that happened with travel cost? From what we kind of went through with face-to-face interactions and the cost of companies, it was important to have face-to-face interactions.
The lower the travel cost, the more office space people were willing to pay for it.
Okay, or holding kind of the area with the blocks constant. What happened to cost as you were further away from the center? What was the relationship? Did it go up at a linear rate or an exponential rate or a declining rate? It was exponential. So which one of these characterizes an exponential type of impact? Two. Right? So that's kind of the first step to this, is that based on the earlier discussion of travel costs, which one of these does that? If you kind of map out 0 to 5 if you want, making your own little model of travel cost, then the beta equal to 2, we could do a couple of them here. So the travel cost was C equals 12 plus X to the beta. And so if you 0, 1, 2, 3, 4, 5, what is it at 1? So what's the cost at 1 when beta, and this is, let's just say for beta, beta equal, just let's do squared.
54.
54, how'd you get that?
12 plus 1 times 1 times 2.
So here we're just looking at the travel cost.
1 to the 2.
It's 37.
So the travel between firms is C equals 12 plus X to the B. So at a travel distance of 1, what is it, Jonathan? 13. Just 13. Were you adding them all? I was thinking you're maybe adding them all together.
I was looking at the other table.
Yeah, so you could, the total cost of production would be 60 minus 6X plus 12 plus X to the B. And that might end up being 50. I don't know, I didn't do that one. But you can look at the total cost of production. Here I just want to kind of think about isolating the travel cost. And so at 1, it's 13. And what is it at 2?
16.
16. So at 2, we get 16. And what is it at 3?
21.
21. 4.
28.
28.
37.
37. So now it's starting to get, so we got this thing going up like this, right? With the squared function. If we did the 1 function, what would it look like?
Straight line.
Straight line, and it would just be 1 to 1, right? Kind of going like that. And if it's a half, it would look like that. And so they're just trying to kind of get you to think about the functional form of, you know, what would it do earlier? It increases exponentially. So let's do 2. So illustrate the cost minimizing location for a firm, including a value for X star. So now cost minimizing location, go ahead and use 2 for part B. And what's the cost minimizing location? Now you got to take into account the wage and the travel cost. Where should we locate? Could actually do the 60 minus the wage one just for fun here. I guess that's part of what Carlos was doing, I think. So 60 minus 6 is 54. That's where you got that, right? So that would have been up here at 54 somewhere. And then at 2, 6 minus 12, or 60 minus 12 is 48, right? So then we're basically going to have something doing this and this one doing this. And where do we locate? Should we be at 0 or 1 or somewhere in the middle? 3 you got. Why'd you get that?
Well, you said add both, like what I got in the wage formula and the cost formula, adding together.
So that's where the two lines crossed, or?
Yeah.
Okay. So if we're doing cost minimizing, what do we need to do? What do we need to be mindful of if we're trying to choose? We have two competing factors, first of all, right? We've got high wages and low transaction costs, or we got high transaction costs and low wages. So what do we need to focus in on? What do we need to calculate to determine this?
Marginal cost.
Marginal cost. What's the total cost? Marginal cost would be the incremental changes, which is kind of what we're
It's
doing.
just the labor cost plus the interaction cost.
Labor cost plus the interaction cost. That's what we want to minimize. And so, Carlos, where you sound pretty confident here. Where does it minimize?
3.
At 3. You got that too, McKenna? I see a head shaking. So how'd you get it?
Adding
Adding the 2.
both cost to revenue.
Okay, and
And 63.
63 is the level.
Yeah.
And how do I know that that's the minimum?
Because is the minimum.
What do you mean? Did you try, what is it at 2?
64.
64. Okay, so now we're getting somewhere. So you calculated 64 there. What was it at 3?
63.
63. What was it there?
64.
64. What was it there?
Yeah, 67. 67 too.
All right, who's lost? Okay, good. Jonathan's lost. So what are these things?
W plus C.
W plus C, it's just the total cost. So the total cost function is 60 minus 6x, which covers the wage, plus my cost of 12 plus x squared, since we chose beta to be that. And then you just did plug and chug,
Yeah.
correct? The old plug and chug, shove in a 3, get the answer. So each one of these circled things here is the answer for being different distances. What was it at 0? 72. These collapse away, so that's 72. So old plug and chug, just kind of change, figure out the numbers and see which one is the least costly. Okay, any questions or comments there? And so if we did do a nice picture, 3, remember in the other graphs, let me just put one up here since we talked about it in this chapter. What would this picture look like with the numbers that we just went through? It would be this
There would be a
or
curve going up.
this. It'd be U-shaped, right? So this line in the middle, total cost, would be U-shaped if we map this out. And all you're doing each time is you're adding the two costs together to get 72, 67, 64, 63, and so you're going to have a U-shaped look if we were to graph those out. Okay. How about number 4? These are kind of, a couple of these are just kind of working through what the changes would be. So consider a model-centric city that improves its local schools, boosting student achievement in an efficient manner. To simplify, ignore the effects that the achievement has on worker productivity. So we get local schools boosting student achievement, but yet we're going to ignore anything that has to do with worker productivity. In the residential land market, what would happen? Let's just kind of talk through this one. What would be better schools, residential land market?
People would probably be, are we writing this down or just saying?
Just saying it for now.
People would probably be willing to pay more.
Okay, people would be willing to pay more, right? Better student achievements, there's some sort of benefit there that's can be captured with some sort of estimate. So in A, if we had a residential, what would happen in the land market? Well, they'd be willing to bid more. So there'd be an increase in the bid rent function. Which would be, from those pictures we were doing, some sort of shift up. If we translate that to kind of a supply-demand framework, where we have the demand for land and the supply of land, then there'd be an increase in demand, and that would shift up, right? So those two things kind of play together, is the reason I bring that up. The bid rent and putting it in a market context. In the business land market, the changes in the labor market cause what? Now here it says the changes in the labor market. So what's going on in the labor market? Because it says, consider this, local schools boosting achievement, ignoring effects, they're willing to pay more.
Wages go up.
Wages are gonna go up, right? Because we're gonna have more people, wages go up. What happens to the bid rent function for the businesses? It goes down because of the leftover principle. So labor gets more expensive because of these stupid new schools, and now we have in the business land market possibly a decline there. All right, so using 14.3, just to kind of bring us back to what he's getting at there. 14.3 is this one, I think. Which is essentially what we're doing. I don't have that. I want to make sure. I think that's right. I thought I had my little labels now. Oh, I guess I could just put back on this. Yeah, that's our 14.3. Okay. Number 6. Suppose a monocentric city imposes a tax on manufacturing firms. What's going to happen in the business land market? It goes down, so we're imposing a tax on manufacturing firms. So leftover principle means there'd be less there. In the labor market, the changes in business land market, what happens? What's the trickle into the land market? So in the labor market now, the changes in the business land market, so he called this chapter, remember, general equilibrium, so we're trying to connect the dots from market to market and think about the impacts as they trickle through. So the tax makes a lower bid rent there.
Increase wages?
Increase wages, why?
Because the businesses aren't paying as much for their land, so they can afford to pay more.
Yes,
But the tax,
but the tax.
Yeah.
Is
but I know in the last question, whenever business land market decreased, the wages went up, so.
we want to focus it in on the business. It might have for a different problem, but not necessarily for this one with the leftovers. So the tax is causing us to not be able to buy as much of land, right?
It would go, you'd employ less people because you'd have a smaller space.
Okay. So less people, smaller space, and so in the labor market, what would decrease in demand for labor? Okay. And so what would that happen? What would happen with that?
So wages would go down.
Wages would go down. So in the residential land market now, the changes to the labor market
Low wages means they'll offer low prices.
will cause a down, right? So yes, in the labor market, so less wages, less income, then can they afford to buy as much? No. So their bid rent's gonna go down. So it's kind of this downward spiral. Have the government throw some stupid tax into the system, and there might be effects that kind of spiral down into other places. Maybe it was a good tax. I take that back. Those manufacturers were probably doing something really bad that they deserve to be taxed on. Okay, so that is our review for this. So you've got the odd numbers for Thursday before class, so we can review them Thursday. All right, back to this next chapter is really, I think, kind of cool. I think you guys will find it kind of eye-opening. All right.
Chapter 14 is due before class Thursday.
I'm sorry, Wednesday night.
That's what I.
Yeah, that's what I put in the announcements, yeah. I was just thinking we want to talk about it, go over questions on Thursday. So yeah, Wednesday night, and then Thursday night will be this chapter here. Okay, so neighborhoods. What's a neighborhood? How does a household choose a neighborhood? Are neighborhoods homogeneous or heterogeneous with income, education, and race? What are the consequences of segregation? Segregation? I thought we got rid of segregation. Wasn't that the 1964 Martin Luther King segregation of schools? What forces lead to a relatively homogeneous neighborhoods, even in the absence of explicit preferences for like neighborhoods? Okay, so first of all, I want to demystify segregation. What does it mean for a neighborhood to be segregated? Jameson.
There's like more like some like race on one side, and like other side it's another race.
Yeah, so it could be race, it could be income, it could be age. So there could be different things. So the point is that I wanted to bring up is that it doesn't have to be forced. So the thing that we got rid of was forced segregation. Black, you guys have seen the videos, black, whites only drinking fountain, you know, that type of thing with neighborhoods. That was somewhat allowed to be legal, to where it was illegal at the time for a black to buy a house in this neighborhood, for instance, or something along those lines. So segregation was actually the law of the land, if you want to think of it that way. Like let's keep separate. So what we see today since then is, despite having laws wiped out, we still see segregation by race and income and age. So there's something human going on. Maybe there's something institutional going on that's not necessarily the law of the land, but something else going on. So that's part of what we're going to investigate with this chapter. Why do people make these choices, and what are the choices? So from an economist standpoint, we're just going to look at the data and say, here's what we're looking at, and see if we can try to make some conclusions and questions. So here's Boston per capita income. So per capita, per person income. So we have a population in each one of these areas, which I believe is down to the county level is how they have the data. In the whole Boston, or I'm sorry, the city, this is city level data, I think, in what the Boston area of these neighborhoods. So sometimes it's hard to like, well, what's a neighborhood, where's the line? So they eventually have to kind of have a line, and usually we'll do governmental jurisdictions on stuff like this. So, where's the rich people?
In the bigger area.
Away from the sea.
Right here is some, right? So there's the high end of the income spectrum, and then we've got little pockets of low income areas, right? So we see some segregation, and not necessarily saying this is good or this is bad, it just is what it is. This is what we find empirically looking at it. College degrees in Denver. So this is the number of degrees per 1,000 people. So basically in the white areas, it's somewhere between 0 and 20% of the average person you walk on the street. Do they have a college degree or not? And now we're 60 to 80% in these areas. So the average person you bump into on the sidewalk, there's a 60 to 80% chance that in that neighborhood, they have a college degree. Okay, so we see segregation picked apart by those metrics, and we kind of see areas where it kind of fans out, but there's definitely concentrated areas in these particular neighborhoods. All right, Atlanta, racial segregation. Number of blacks per 1,000. So again, 0 to 20%, this is still the Atlanta area, is 0 to 20%, 80 to 100% in this section. In terms of the average person you walk into on the street in this neighborhood, you've got an 80% chance that that person is going to be black. Average walking on the street here, it's a 20% chance, right? So concentrations in different neighborhoods and different places. Here's race in Pittsburgh. And I can't remember if this is the river. I think it's the Three Rivers. That's what, isn't it Pittsburgh Three Rivers Stadium even, where the Pittsburgh Steelers play their games? So that's the rivers, I think, coming down there. So that's near the downtown area. So definitely really concentrated pockets in different areas. All right, so how can we measure this stuff? So give this a read. Okay, so kind of hang your hat on this idea of integration, integrated, or segregated. Are they really separate, or are they really mostly homogeneous throughout, depending on what segment we're looking at? So 0, perfect integration, 100 are highly dissimilar, segregated. So this index is a way to measure that. It's kind of a fun little tool. I had to do a lot of little researching, and the next slide I'll give you my source. I just I didn't do it this time, but last time I went through this. So we got a formula where we're going to take people types, and we're going to look at how similar or dissimilar they are based on whatever that demographic is. So down here, I've got 3 different setups. Which one is the most integrated? A, B, or C? Well, I should use 1, 2, or 3. So here's the setups. These are neighborhoods within each city. Which one is the most integrated? 1, 2, or 3?
2.
2. Which one's the most segregated?
2, 1.
1, right? So 1 has 100% in each of the smaller neighborhoods. Okay, so let's figure it out for yourselves. I want you guys to apply that formula. I'll walk around the room, but using a pencil and paper, plug and chug this setup. So there's n neighborhoods of 3, A, B, and C. A, 6, 6, 0 of the A types in each one, which is the yellow here. And B, 0, 0, 6, all of the 6 are here in neighborhood C. So the answer I'm giving you, this setup is going to have a dissimilarity index number of 100, but I want you to use that information and write out the full formula. Use that formula and write it all out and calculate it for yourself. It's not as hard as it looks like it's going to be once you kind of get your fingers dirty here. And I guess let's make sure everybody's cool with the sum sign here. What does that mean? Let's see. The sum so the sum of I equals 1 to 3 of xi. What is that? How do I break this down? I'm trying to stay away from this problem. What does this tell you to do? Your answer is equal to, so whatever, B beauty equals that. How does this little sigma summation thing work?
Anything following it in the brackets you have to add together?
Everything following with the I, you add together. So this equals, this is just shorthand notation. This could be 300, by the way, right? So it's just 3, it kind of makes it easy. But this is shorthand notation to just say take x1 plus x2 plus x3. So that's what you're doing with this formula. From I equals 1 to 3, you're going to solve that stuff that's in the brackets. What's the 2 lines mean? Absolute value, which means what do we do? Take the positive of whatever's inside, however that calculates. All right, you can work with your neighbor. I'll walk around the room if you need a little nudge to get started. But otherwise, just get your hands dirty, and it's 100 times 1/2 times the sum of that stuff. Super fun. Yeah, at this point, don't even worry about your calculator for the most part. You can just lay it out with numbers. That's the hardest part. Trying to figure what? So with A, since it says AI, it's saying A1 is 6, A2 is 6, A3 is 0. So there's 0 A's, which is the yellows. There's 0 A's in the third neighborhood. so yeah, you're good with, I'm glad you put the big brackets over here. But now, within each one, where did you get the 6 over 6?
The 6 in A are yellow.
Okay, that is the big A. So big A is the citywide population. Remember, these are 3 neighborhoods. So it's a 12, yeah. So the big A, the whole city is this. These are 3 neighborhoods within Atlanta or whatever. Like we were just doing, showing Boston and Atlanta and Denver. And now for each one, you need to do that absolute value thing.
Wait,
Talk with your neighbors. I'll walk around the room and give you the just. Okay, so. Okay, so I'm trying to think if you. I think you're not like showing this right, but I think you did the right thing. So yeah. So what you're trying to do is take away the sums thing. And so 100 times 1/2. And then go into here and do like what I did with x1, x2. So it's that plus that is in the brackets. Yeah. That'll, I think you got it. So that means that's where you're going to get this A1 plus A2. So yeah, that's right. Yeah. So this is the A1 over the A, and then the next one is the A2 over the A, right? So yeah, you've actually got it set up just fine. Okay, yeah. So you're on the right track. Just going to set that up. What else, Jonathan? Okay, you were kind of doing, I think, what Jacob did. So instead of keeping the sum here, just start to write it out like the x1 plus x2 plus x3. So it's A1 over A minus B1 over B. That's one of the ones, one of the neighborhoods, right? And then it's plus the next one that's in the brackets, which is going to be A2 over A, B2 over B, and then it's going to be the next one. So you won't have the sum thing if you kind of set this up to be just basically 1/2 of that. And then there should be plus something and plus something. So there's a chunk, and then this chunk.
Was that first chunk right?
The first chunk is not right. So how much does A1 have? 6 out of how many for the whole city? No, for the whole city of the yellows. Population of the yellow is 12, so that would be 6 over 12. Okay, Carlos.
I just said, like 1 unit up there.
Yeah, that's
I'd like to see it laid out, so this is what I've been telling these guys too, kind of like what Bryce was doing here. So after this, get rid of that sum sign and then just take the 3 parts. I don't know off the top of my head. I think you're right. Oh, I see. These are your 3 parts?
Yeah.
Yeah, I think that's right. That looks right. 2, but then don't forget the 100. So what you're missing here is it's 100 times 1/2 times that big chunk. Yeah. So there's your chunk, there's your chunk, there's your chunk. That equals 2 times 1/2. Oh, I see. You did the rest of it. Yeah. Yep. Just kind of piece it together. All right. I think I got around to everybody's sheet. So here it is. Mathing it out, there's your chunks, and it's absolute values, so that comes in here, right? 0 minus 1 is a -1, but it's actually treated as a +1. And so the formula, the reason we use those absolute values is we just want to know are they different or not, right? And it doesn't matter if B is put first or A is put first, is the reason for the absolute value. And then we've got the 1/2 plus 1/2, so there's the 2, and that equals your 100. So this city is perfectly dissimilar in terms of the neighborhoods are perfectly segregated. Okay, since that was so much fun, do this one. Now that you got it down, it should be a lot easier. This one was perfectly integrated. I just thought of a fun exercise. You guys could do the dissimilarity index per floor in the dorm rooms. Like treat each floor as its own neighborhood. And then you could take some metric and create a dissimilarity index for each dorm floor. So how does each dorm, the building is the city, and then how much does each floor vary by some demographic? Anybody need a nudge? Yeah, the answer is 0. So yeah, I gave you the answer. You should come up with a 0. I just want you to prove that you got to 0. And be able to lay it all out. Yeah. Yeah. Okay, so from here, it's almost better to keep it generic. So you're going to be, this is equal to 100 times 1/2.
That's fine.
And then the 3 chunks are going to be here. The 3 chunks are 4 over the total for the community, which is still 12, right? So it'd be 4/12 minus the B level, which is 2, which is 2/6, which is what you were doing there, right? And that's 1 chunk. And then now you're going to do that for each of the chunks, and you'll get your answer. All right, so you can check your work here. We'll call it a day, but here's the 3 chunks. So 4/12 minus 2/6, blah, 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 zeros across the board, and you get a 0. All right, we'll pick up there on Thursday.
God,